I want to start off by posing this central question to you. What has the most powerful telescope in history actually found in just 4 years? Well, Webb's unprecedented power to capture invisible infrared light has suddenly brought things that were previously impossible to see into crystal clear view. It's giving us a wildly powerful new set of tools to explain our place in the cosmos. And honestly, the sheer volume of what we're looking at here is it's staggering. Over these last 4 years, the observatory has collected nearly 900 terabytes of publicly available data. To put that into perspective, that's equivalent to millions of high-definition movies flowing back to Earth, allowing us to see deeper and with way more precision than humanity ever has before. Okay, let's dive into this. That literal mountain of data has already prompted more than 2,600 research papers. I mean, that's allowing scientists to ask entirely new questions and find answers to mysteries we didn't even know existed. So here's our roadmap for today. We've got 1. Unveiling the invisible. 2. Rewriting the early universe. 3. Penetrating galactic dust. 4. Oceans in our backyard. And 5. The journey just began. Basically, we're taking a macro to micro journey today, starting at the very edge of time, traveling through glowing galactic dust, and finally zooming right back into our own cosmic backyard. Number 1. Unveiling the invisible. Seeing the universe in infrared. Researchers aren't just pointing Webb at uncharted sky. They're actually using it to tease out brand new details from older Hubble, Chandra, and Spitzer observations. And this brilliantly illustrates the sheer variety of cosmic phenomena Webb can uncover. By looking through space with its unique infrared toolkit, we're unveiling stars hidden deep inside dusty cocoons, spotting the remnants of exploded stars, and peering right into the dense hearts of galaxies. We're even tracking weather on gas giants and hunting for atmospheres on rocky exoplanets. It's giving us this completely comprehensive, three-dimensional view of our cosmos. All right, number 2, rewriting the early universe, journey to the edge of time. So Webb has enabled us to look back across almost all of our universe's 13.8 billion year history, looking right into what we call the cosmic dawn. It's a pretty poetic term, right? It basically defines that crucial, mysterious era during the first billion years when the very first stars and galaxies were just starting to form. And Webb was specifically designed to peer right into this ancient era. But wow, look at the massive gap between expectation and reality here. Going in, scientists expected to see just a few faint hints of early galaxies, maybe the tiny seeds of what would eventually become galaxies like our own Milky Way. Instead, what Webb actually found were surprisingly bright, mature galaxies that developed super rapidly, complete with incredibly massive black holes. I mean, finding these mature structures so early on is literally like finding a fully grown adult sitting in a kindergarten classroom. It completely upends our models of cosmic evolution. Let's walk through this timeline because it changes everything. Right after the Big Bang, 13.8 billion years ago, Webb shows these surprisingly bright galaxies developing within just 300 million years. By 600 million years, an infant Milky Way-type galaxy existed. And within just 1 billion years, some galaxies had already kind of turned off and stopped forming stars altogether. This absolutely proves the early universe evolved exponentially faster than physics previously thought possible, enriching itself with elements at an astonishing rate. Moving on to number 3, penetrating galactic dust, masterpieces closer to home. Now we're going to shift our focus closer to home, moving from the literal edge of time back to nearby galaxies. Webb's powerful infrared vision actually allows us to pierce right through thick, obscuring clouds of gas and dust. A captivating prime example of this is the Phantom Galaxy, which was completely invisible in this kind of intricate detail to older telescopes. Now, what's really interesting about this is how it breaks down the specific structures Webb can isolate. We don't just see a blur anymore. You've got these expansive spiral arms with lanes of warm dust and giant bubbles literally carved out by hot young stars. It perfectly separates those volatile young star bubbles from the cool, dust-free core, which glows with older, vibrant blue stars. Okay, number 4, oceans in our backyard, surprises in our solar system. Webb isn't just for deep, ancient space. It is fundamentally changing how we view the planets and moons we thought we already knew so well. Right in our own local cosmic neighborhood, it's tracking everything from planetary rings, auroras, and high-speed winds to sizing up local asteroids and mapping out complex ices and gases. It's totally vital for understanding exactly what our own backyard is made of. But among all these icy ocean worlds, the absolute ultimate prize for astrobiologists hunting for life is Saturn's moon Enceladus. NASA's Cassini mission had previously detected water plumes coming out of its southern pole, but it actually took Webb to reveal the true, shocking scale of what was happening there. So the crucial point is the sheer mind-blowing scale here. Webb proved that the water plume is a vast cloud spanning more than 6,000 miles. That is about 20 times wider than Enceladus itself. This massive geyser is spreading out to actually encircle Saturn, reaching far beyond its visible rings. It's completely forcing us to rethink the mechanics of these ocean moons. And finally, number 5, the journey just began, the future of Webb. As we wrap up our spatial journey today, remember that despite all these mind-bending discoveries we've talked about, we are still at the very start of this mission. And here is the absolute best part. Because Webb was launched with such incredible pinpoint precision, it saved a massive amount of propellant. It actually carries over 20 years of fuel on board to keep answering these vast new questions. So I'll leave you with this provocative thought from the researchers themselves. There is still so much waiting to be discovered by the most powerful space telescope humanity has ever built. I mean, if Webb has entirely rewritten our understanding of the early universe, found impossible galaxies, and revealed 6,000-mile water plumes in just 4 short years, what impossible discoveries do you think the next 2 decades might bring? Thank you so much for joining me on this explainer. Keep looking up and stay curious.